Tesla Optimus, the company's humanoid robot, is gradually shaping up to become a game-changer in manufacturing and households. It is designed to automate repetitive tasks that require continuous labor. Additionally, expectations for its impressive features with a high degree of refinement make Optimus ready for launch at any time. So how will the Tesla bot make a breakthrough when it hits the market in 2025? That's what we'll dive into in today's episode. And welcome to Techno Creators. Before we begin, please help us reach 3,000 subscribers. It will be a huge motivation for us to continue bringing you great tech episodes. Optimus offers a glimpse into the future of factories with advanced real-time sensors and artificial intelligence, proving to be a versatile asset capable of transforming production lines worldwide in assembly line settings. It can take on tasks requiring precision and consistency. Imagine the Tesla bot tightening bolts, assembling small components, or even wiring intricate parts. Its dexterous hands and advanced software enable it to perform complex operations that demand a steady hand. This potential was highlighted when Elon Musk shared goals like threading a needle and plans for a redesigned hand featuring 22 degrees of freedom. Additionally, Optimus excels at performing repetitive tasks without fatigue, ensuring consistent quality levels, something human workers often struggle to maintain during long shifts. Material handling is another area where Optimus stands out. Whether it's transporting raw materials, loading items onto machinery, or moving finished goods to storage areas, the robot's efficiency is unparalleled thanks to its integration of barcode scanning or radio frequency identification technology. Optimus can also assist with real-time inventory management, ensuring factories run smoothly without delays caused by misplaced items. In fact, safety is a major advantage that Optimus brings to factories. By performing tasks in hazardous environments, such as areas with toxic substances or extreme temperatures, it minimizes risks to human workers. Additionally, the robot can handle heavy or irregularly shaped objects, reducing workplace injuries caused by lifting or moving such items. Optimus isn't limited to routine tasks. Its ability to learn allows it to adapt to changing production demands. If a factory layout is reconfigured or a new product is introduced, the robot can be updated to take on new responsibilities. This adaptability sets it apart from traditional robots, which are typically confined to a fixed range of operations. Collaboration is another standout feature of Tesla Optimus. Designed to work alongside human workers rather than completely replacing them, it can handle repetitive and physically demanding tasks, freeing employees to focus on roles that require creativity or problem-solving skills. This is particularly valuable as factories face challenges like labor shortages and increasing demand. In terms of efficiency, Tesla Optimus is emerging as a solution that combines cutting-edge technology with practical applications. The future of manufacturing is likely to be a space where humans and robots collaborate, achieving unprecedented levels of productivity and safety. When did Optimus mass production take place? Elon Musk once commented in a post on X, stating, "Tesla will produce truly useful humanoid robots in small quantities for internal use at Tesla next year, and hopefully mass production for other companies by 2026. Tesla showcased its humanoid robot, Optimus Gen 2, at its exhibit during the World Artificial Intelligence Conference 2024 in China. Later, Musk shared that Optimus Gen 2 features a new design for the Tesla robot, which will be finalized by the end of 2024. He revealed that the new design for Tesla Optimus is something special. Finally, we witnessed Tesla Optimus's new hand design during the We Robot event, as shown in video footage where the robot caught a tennis ball using its newly designed hand. Tesla has indicated that the company will begin field testing with Optimus. This effort requires an experienced technical program manager to drive the deployment of robots for pilot applications. A recruitment posting suggests that Tesla has already conducted field tests of Optimus at its gigafactories across the United States. Thus, Musk's prediction regarding the initial production and use of Optimus may very well be accurate. However, Musk's projections could change depending on Tesla's ongoing work on Optimus. Previously, he estimated that Optimus would be ready for external sales by the end of 2025. Based on his recent statements, the timeline has shifted slightly. Earlier, Tesla was reported to have discussed building a factory in South Africa as far back as 2016, with the potential for constructing a facility to produce 4,680 batteries, the core component inside Tesla Optimus. The figure of 10 billion robots may sound like a scam because it seems so unbelievable that it feels impossible. It even surpasses the global population, implying that each person would own at least one or perhaps even two Optimus robots, as Musk once suggested. If Tesla were to actually produce and sell 10 billion robots at $20,000 each, the revenue would reach an astronomical $200 trillion. Moreover, millions of robots could be deployed in factories to revolutionize production processes and possibly form a fleet for delivery operations. This easily explains how the number of Optimus units would far exceed the global population. As such, the robot's potential is limitless in terms of capabilities, functionality, utility, and productivity. Therefore, we don't believe Elon Musk's projection of 10 billion robots is an exaggeration for the future. The initial steps to affirm the mass production plan for Tesla Optimus seem to have started since Tesla revealed plans to upgrade the 4680 battery cells used for Optimus and its electric vehicle models. So, what made Tesla decide to use the 4680 cells for the Tesla bot? Let's dive deeper into this, but first, don't forget to give a thumbs up and subscribe to support the information we provide. Why does the new Tesla 4680 Gen 3 battery have such an advantage? The first principle: the new 4680 Gen 3 gets benefit from changing the composition of the battery materials. The new 4680 Gen 3 battery represents a major leap forward in battery technology, and this advancement is driven by strategic changes in the battery's material composition and structural design. These improvements not only enhance energy density, but also contribute to cost efficiency and sustainability. One of the most significant changes in the new 4680 Gen 3 battery is the alteration of the cathode composition. The older generation 4680 Gen 2 battery used an NMC8111 cathode, consisting of 80% nickel, 10% cobalt, and 10% manganese. In contrast, the new battery employs an NMC955 cathode, with 90% nickel, 5% cobalt, and 5% manganese. This increase in nickel content is crucial because nickel-rich cathodes are known for their higher specific capacities, directly translating to greater energy density. By increasing the nickel content to 90%, the energy density of the new battery is significantly enhanced. Nickel's higher specific capacity allows the battery to store more energy per kilogram, making it more efficient and capable of delivering longer ranges for electric vehicles. Moreover, reducing the cobalt content from 10% to 5% offers multiple benefits. Cobalt is an expensive and often ethically problematic material, with supply chain issues linked to human rights concerns. By decreasing the cobalt content, Tesla not only reduces the cost of the battery, but also improves its sustainability profile. This change aligns with broader industry trends towards minimizing cobalt usage due to its high cost and ethical sourcing challenges. Similarly, the reduction in manganese content from 10% to 5% further supports the increase in energy density. Manganese has a lower specific capacity compared to nickel, so decreasing its proportion allows for more nickel, thus boosting the overall energy capacity of the battery. These material optimizations make the 4680 Gen 3 battery not only more powerful, but also more cost-effective and environmentally friendly. Another pivotal innovation in the new 4680 Gen 3 battery is the use of asymmetric lamination for the electrodes. This design involves applying a thicker active material coating on one side of the electrode, which significantly increases the energy storage capacity. The thicker coating allows for more active material to be included in the same volume, thus enhancing the battery's energy density without compromising its physical dimensions. This structural innovation, combined with the improved cathode composition, leads to a substantial 10–20% increase in energy density compared to the current 4680 Gen 2 battery. Specifically, the energy density of the new 4680 Gen 3 battery ranges from 1,200 to 1,400 watt-hour per kilogram, a marked improvement from the 244 to 296 watt-hour per kilogram of the current generation. In terms of total energy, the new battery offers between 105.6 and 118.8 watt-hour, compared to the 96 to 99 watt-hour of the older model. The second principle is from the tabless design structure principle. The shift from a tabbed to a tabless design structure change addresses several limitations inherent in the older design and enhances the battery's performance, efficiency, and safety. Traditionally, battery cells used a tab design where electrodes, anode, and cathode were connected to the cell casing via metal tabs. These tabs served as current collectors, channeling electricity from the electrodes. While straightforward, this design had several drawbacks. The numerous tabs created higher resistance within the cell, leading to increased heat generation. Additionally, the presence of multiple tabs limited the packing density and mechanical stability of the battery, thereby heightening potential safety risks associated with tab failures. In contrast, the new 4680 Gen 3 battery employs a tabless design, a revolutionary approach that allows the entire flat surface of the electrodes to function as current collectors. By eliminating the need for separate tabs, this design significantly reduces internal resistance, thereby enhancing power density. The larger active electrode surface area enables higher power output and faster charging capabilities. This efficiency gain translates to quicker charging times, a critical factor for electric vehicle users. Moreover, the reduction in resistance within the cell means that less heat is generated during operation. Lower heat dissipation not only improves the overall efficiency of the battery, but also enhances its safety profile. With fewer components to fail, the risk of mechanical failures is minimized, making the battery more reliable. In addition, this tabless design also contributes to better mechanical stability and increased packing density. Without the bulk of numerous tabs, the cells can be more densely packed, allowing for more efficient use of space within the battery pack. This results in higher energy storage capacity, further extending the range of Tesla vehicles equipped with the 4680 Gen 3 batteries. How has Tesla prepared for this mass production of the new 4680 Gen 3? Elon Musk's meticulous preparations for the mass production of the new 4680 Gen 3 battery, scheduled for late 2024, reflect a strategic approach designed to revolutionize Tesla's battery technology and production capabilities. If anything, the launch is taking up a lot of Tesla's time and manpower, and there has never been a problem or a denial about this from Musk. The first step is to build a solid foundation by capacity expansion and gigafactory construction. One of the key components of Tesla's strategy is the rapid expansion of its battery cell manufacturing capacity. The focus has been squarely on the new 4680 Gen 3 cell, which promises significant improvements in energy density, cost efficiency, and performance. To accommodate the production of these advanced cells, Tesla has invested heavily in building new gigafactories in Texas and Germany. These state-of-the-art facilities are dedicated to producing the 4680 Gen 3 cells at scale. According to Tesla's Q4 in 2022 earnings report, the company aims to achieve an impressive production rate of 100 gigawatt-hours per year by the end of 2024. This ambitious target underscores Tesla's commitment to scaling up production to meet growing demand for batteries in electric vehicles manufacturing. Besides, another cornerstone of Tesla's preparation strategy is forging strong partnerships with major battery suppliers such as Panasonic, Samsung CATL, and LG Energy Solution. Tesla does not currently use battery cells supplied by Samsung SDI for its electric vehicles. These collaborations are crucial for the joint development and production of the 4680 Gen 3 cells. Panasonic, for instance, has already commenced production of the new cells at its facility in Japan, with plans to ramp up annual capacity to 10 gigawatt-hours by the end of 2024. Similarly, Tesla's partnership with LG Energy Solution aims to produce 8 gigawatt-hours of 4680 Gen 3 cells per year, sufficient to power approximately 110,000 upcoming Tesla electric vehicles. These partnerships not only enhance Tesla's production capacity, but also ensure a steady and reliable supply of high-quality battery cells. Along with that, the company also conducts a parallel plan between ramp-up production, but also continuous testing to produce the most optimal results. Extensive testing and ramp-up production efforts have been integral to Tesla's preparation for mass production, and it has become a tradition that could not be more typical of this company. Tesla has established pilot production lines for the new 4680 Gen 3 cells in California and Texas. As reported in the Q4 in 2022 earnings call, Tesla has already produced over 1 million cells, demonstrating the feasibility and reliability of the new technology. Recently, Tesla achieved a significant milestone by producing a total of 50 million new 4680 Gen 3 batteries in Texas, equating to an output of approximately 120,000 cells per day. This rigorous testing phase ensures that any potential issues are identified and addressed before full-scale production begins. In conclusion, Elon Musk's thorough preparations for the mass production of the new 4680 Gen 3 battery highlight Tesla's strategic foresight and commitment to innovation. What features of this 4680 Gen 3 battery impress you? Do you want to use them for your Tesla soon? We would be happy if you leave comments about this. We hope you'll experience the most relaxation after watching this episode. If you do, please press the like button and join our channel by subscribing to our channel. Hit the notification bell icon to stay tuned for any fantastic videos coming your way. Thank you so much for watching, and we look forward to seeing you soon. Until